Yeah, well, this is the second video on chi-square test. In this video, we'll come to know how to test hypothesis for population variance when sample variance is unknown. In my last video, I let you know how to test hypothesis for chi-square test when sample variance and population are known. Whereas in this case, I have to calculate sample variance out of the given samples. So this is a different method than we calculated earlier. Then let us consider a problem for testing a hypothesis. In this problem, the 12 measurements of the same object on an instrument are given below. An instrument, 12 sample of an instrument are given below. And what we want to do is, if the measurement of the instrument follows normal distribution, obviously any chi-square test under parametric test must follow the normal distribution, then carry out the test at 1% level of significance that variance in the measurement of the instrument is not less than the 0.016. It means we have firstly 12 samples, that n is equal to 12, and we have 12 samples and we have to test at 1% level of significance. We have to test that variance in the measurement of the instrument is less than 0.016. So which means we have population variance. So population variance is equal to 0.016. 0.016 is our population variance, and the sample, we have 12 sample. So for these 12 sample, we have to test at 1% level of significance. In keeping our mind, variance in the measurement of the instrument is less than 0.016 variance. So here we have sample size, and also we have here alpha, and also we have here population variance. But here we don't know the sample variance. Sample variance is unknown in this case. So we want to calculate the sample variance. So firstly, let us formulate a null and alternative hypothesis. For any type of problem, we can firstly formulate, and we have to firstly formulate null and alternative hypothesis. Then we have to obtain the level of significance. After obtaining level of significance, we can decide the type of appropriate test for the given problem. So in this slide, I will show you what are the given things with us and what we want to calculate in this problem. So sample size, as I told you already, we have 12 sample size, and sample variance, we are not aware of sample variance. We have given a sample size. So out of these samples, we have to calculate variance, and we also having population variance, and also we having alpha level of significance. So for which we have to formulate a null and alternative hypothesis. To formulate null and alternative hypothesis, firstly we have to concentrate on the claim. What is the given claim? We have to concentrate firstly. Here in this problem, we want to test the variance, which means population variance in the measurement of the instrument is less than 0.016. So which means we have to go through the claim. So which is a claim? Then our claim would be, claim is variance less than 0.016 is our claim. So we want to thoroughly concentrate on the variance of population, and they have told us to calculate in the measurements of instrument is less than 0.016. Since it is a variance, our alternative complement would be variance would be greater than or equal to 0.016. And as usually our complement contains equality sign, we will take complement as null hypothesis. So now our null hypothesis is variance greater than or equal to 0.016, and our claim would be our alternative hypothesis. So our alternative hypothesis is variance lesser than 0.016. And we have to concentrate one more thing on the alternative hypothesis, that our alternative hypothesis contains one-tailed test. This is a one-tailed test. So rejection region falls in the sample chi-square distribution in the right side of the distribution. So which indicates a lesser than type in the alternative hypothesis. So in the sample distribution, rejection region falls in the left side of the sample distribution at 1% level of significance. And here we want to test hypothesis about the population variance. Our population variance is 0.016 and sample size is 12. Number of sample sizes are given n is equal to 12, which is a lesser than 30. Also we are given that measurement of the instrument follows normal distribution. Here they have told us which is a follows normal distribution. So we can go for X square test. For the population variance, we are dealing here with the population variance, and for population variance in that too, the problem follows the normal distribution perfectly, and we are having less than 30 sample size. So perfectly we can go for X square test. X square is an appropriate test for the given problem. So for the X square test, let us consider a formula. In chi-square test as a X square test as parametric test, we will face two cases. One is when sample variance is known. So when sample variance is known, we will consider this formula X square equals to n minus 1 multiplied by sample variance in the denominator population variance. Based on this formula, I have addressed earlier video in my last video on X square test, which was on this formula. Whereas in this problem, we are not known the sample variance, which means samples are given directly. So we have to calculate sample variance. So for that, we are not going to follow the same formula. We are having another formula for calculating X square test when the sample variance is unknown. So the formula then for this for the same purpose is X square is equal to summation xi minus x bar whole square. In the denominator, same as it is population variance. So xi is a sample values, summation of sample values, and minus x bar, here we need to calculate the mean of the sample, and the summation of this we have to make a whole square. Then we have to take it directly, and after calculating summation xi minus x bar whole square, we will divide the same values by the population variance. Here we can make summation of xi, whereas we need to calculate x bar, and in the problem only we are having population variance, that population variance we have. So we have to calculate x bar. X bar means simply calculating mean. So how to calculate mean here? So x bar equals to 1 by n summation x. If you follow this formula, we can calculate a mean for the given sample. So then firstly we have to calculate that summation xi minus x bar whole square after calculating x bar. Then let us calculate x bar and this portion for the given problem. So here I am going to calculate summation xi minus x bar whole square. Firstly I will consider samples given in the formula. We have 12 sample that I have listed here. When I added all this, summation of x would be 18. And the number of n in this case is 12. We have 12 sample. The summation of x would be 18. Now firstly we have to find out x bar. So here look into the formula xi minus x bar. So once we find out the x bar for this given x information, we can subtract by x values from x bar of each x values. So we can calculate x bar then. So as I told you, for the formula for calculating x bar also, so 1 by n summation x, we have summation x as 18. So 1 by n is 12 in this case, and 1 by 12 into 18. So which means our x bar for this problem is 1.5. So x bar is 1.5. Then 1 by 1, let us subtract the x values. So 1.6 minus 1.5. 0.1, 1.5 minus 1.5, 0, 1.3 minus 1.5, so positive value is here, so minus 0.2, and same thing for all the values I have did here. So 1.5 into minus 1.5, 0, and 1.6 minus 1.5, 0.1. So after subtracting each sample values by x bar, which means mean of the x square of the sample values, now we have to make a summation xi minus x bar whole square. In the second column we are having summation xi minus x bar, and it must be 0, and for the next column we have to take summation xi minus x bar whole square. We have to make this square. So 0.01 into 0.01, 0.01, sorry, 0.1 into 0.1 is equal to 0.01, 0 into 0, 0, 0 minus 0.2 into minus 0.2, 0.04, 0, 0, 0.2 into 0.2, 0.04, and same thing 0.1 into 0.1, 0.01, yes 0, minus 0.1 into minus 0.1, yes minus 0.01, and same thing we have just squared the xi minus x bar values, we have squared the values. So after making all this, we are having the values with us, that summation x is 18 and x bar is 1.5 here. Summation xi minus x bar whole square is equal to, when you take the summation of this, 0.16, and number of sample in this case is 12. So when we obtain this upper portion, numerator portion, we can also apply to the formula. Same thing, same values that I have obtained from the calculation I have pasted here. And as I told you, when the sample variance is unknown, we have to use this formula, and we have already found the upper portion, that summation xi minus x bar whole square we have already found it. And population variance, for this problem we have the population variance as 0.016. we have this value in the formula problem only. Then now without delay we can apply to the formula directly. So summation xi minus x bar, here we have 0.016 just we found out, and the population variance is 0.016. When we divide 0.16 by 0.016, the x square would be 10. So for this problem, our tested value, our x square value is 10. Now we can obtain critical value. First we have to obtain critical value from x square distribution. After obtaining critical value, we can apply to the formula, which means rejection reason. Then we can take a decision out of it. So then let us go for calculating critical values for this. Firstly, you must know that our alternative hypothesis is lesser than or equal to type, so which is a left tilde t-test. But the critical values we have in the table, we have for right tile. For that you need to give a separate treatment. I will show you in this. So how to obtain critical values for x square test, I will show you here. The critical values of test statistics for x square for left tiled test corresponding to n minus 1. As I told you, n is 12 number of sample we have obtained 12. 12 minus 1 equals to 11, where 11 is a degree of freedom at 1% level of significance. So what is that critical value then? Firstly, we have to prepare for calculating, for obtaining a critical value. The preparation would be as follows: x square in the bracket n minus 1, as I shown you here, and 1 minus alpha. Very importantly, why I am doing this, I am dealing in left tilde test, whereas the critical value table, that x square table, I am going to deal with is upper tail test. So when I subtract alpha by 1, I will get left tiled critical values. That is why I am going to subtract 1 minus alpha. So then it would be x square, n minus 1 would be 11, and 1 minus 0.1. So our alpha is 1%. When you make when you convert this into 100%, which is a 0.01, so our alpha would be 0.99. So for 11 degree of freedom and 0.099 confidence interval, our critical value is 3.05. I am using here as confidence interval because I have subtracted 1 by 1 minus alpha. So when I subtracted this, which becomes confidence interval instead of level of significance. So which is a left tilde test, that's why we are looking in the confidence interval. So there is two concepts in statistics while you are getting decision about hypothesis test. One is confidence interval and level of significance, that is alpha. So in this case level of significance given is 1%, and the remaining thing in this problem is confidence interval, that is 99% is confidence interval in this problem. That's why I'm using confidence interval. So for critical values, I will look in confidence interval for left tailed test. Then let us move to the x square table for the same purpose. So this is a x square table, and as you know, this column is the degree of freedom. This column is the degree of freedom, and this is a significance level. In this case, our confidence interval, as I told you, you cannot say this as a level of significance, because level of significance will be up to 10%. In the rarest case it will be 10%, that we have considered up to here. Yeah, this is 1%, 2.5%, 5%, and 10%, 90%, 95%, 97.5%, 99%, 99.5%. Then I will consider the half portion of this as confidence interval, and the line further to line as a level of significance, and before to line as a confidence interval. So our confidence interval for this problem is 0.99, so which you can see here, so for this 0.99 we have to see a degree of freedom at 11%. So 11% is this, and for 0.99, so our critical value we obtained as follows. So our critical value, you can see that critical value is 3.05. So each and every distribution having their own type, you can call this as confidence interval, because since in any of the research you cannot say there is a 99% level of significance. In one word, if I want to define level of significance is some there, you will be not in a position to express your confidence that your research is 100% good and which is a error free. You cannot say like that. For that you will insert alpha and you will remove that that error, and you can say in your research there is a 5% error, in your research there is a 10% error, in your research there is a 1% error. But can you say in your research there is a 99% error? If you say like that, you are not at all having any reason to conduct that kind of research. Okay, so here in the chi-square test, in a chi-square test I'm using confidence interval instead of level of significance. So we also obtained a confidence interval. Now let us go for taking decision with comparison with the confidence interval to level of significance to tested statistics. As I shown you, our level of significance for 11 degree of freedom at 99% confidence interval is 3.05, and our tested statistics is 10. Then let us take a decision. We are arrived at decision for chi-square test. So decision can be taken since the calculated value of test statistics is 10. So our calculated value of test statistics is here 10, and then it is greater than the critical value. Our critical value is 3.5 for x squared from the x squared distribution. It falls here. Our 3.5 0.5 critical value falls here. That means the calculated value of test statistics lies in the non-rejection region. So the 10 we will it will fall here somewhere here, and which is falling in the non-rejection region. What do you mean the test statistics is falling in the non-rejection region? So it means you are not going to reject the null hypothesis. So we do not reject the null hypothesis and reject the claim that reject the alternative hypothesis that at 1% level of significance we reject the claim. So thus we could conclude that the sample provide sufficient evidence against the claim, so the variance in the measurement of the instrument is not less than the 0.016, and our claim was 0.016. So we are rejecting this claim since the sample that we obtained and calculated sample variance and x bar providing us sufficient evidence against the claim to reject this claim. So variance in the measurement of the instrument is not less than 0.016. Thank you so much for watching. Please do subscribe to my Vision Academy YouTube channel. I am giving this lectures on testing of hypothesis. I am addressing all sort of testing of hypothesis. Maybe it is a Z which is already completed. I have given 8 videos on this, and even on the t-test also I have given 6 videos, 4 videos on t-test, and general procedure and the basic and background for testing hypothesis I have made 6 videos. And here in the x-square test as parametric test I have made 2 videos, and in the next video I will address F test. So please do subscribe to my Vision Academy YouTube channel. The videos I'm going to make on hypothesis testing is coming like a crash course. It will be most benefit for you people to formulate a hypothesis and test a hypothesis based on your problem. Thank you so much for watching.